Hi there, this is Mr. Schnitzius. In this video, we're going to work through Activity 38. The first lesson, 38-1, is about the probability of a single event. So we're going to understand probability in real-world situations. We're going to learn what a sample space is and write that out as a list. And we're also going to calculate the probability of a single event. So you may have learned about probability a little bit already in Algebra 1 or in your middle school math classes. But in this video, we're going to start from the very, very beginning. So number 1 says, suppose that you have a cube with faces numbered 1 through 6. A lot of the time, math teachers call this a number cube instead of a die, or instead of saying rolling dice, we'll say rolling number cubes. That's because we don't want you to think that gambling is okay. Okay, please don't gamble. Thank you. Suppose that you have a cube with faces numbered 1 through 6. You will roll the cube 60 times. On how many of the rolls would you expect to get a result that is an even number? Well, let's think about all the possibilities if the cube is numbered 1 through 6. The lowest possibility is a 1, or we could get a 2, or a 3, or a 4, or 5, or 6. So these are all the possible results whenever we roll the cube. Okay, on how many would we expect to get an even number? Well, out of these 6 possibilities, 2, 4, and 6 are even. That's half of the 6 possibilities. Whoop. So we would expect to get, sorry, hold on a second. So we would expect to get about 30. Now, why is that? Well, because in 60 rolls, 3 out of 6, or we could reduce that to 1/2, are even, so half of 60 is 30. On roughly how many of the rolls would you expect to get a 5? Well, out of these 6 possibilities, only one of them is 5, so we would expect about 1/6 of the rolls to come out to be a 5. So 1/6 of 60 rolls would be 10, about 10 rolls. Then the last question, part C, says, on roughly how many of the rolls would you expect to get a number that is 5 or more? Well, 5, not just 5 exactly, but 5 or more. So 5 or more than 5 would be 6. So 2 out of 6 reduces to 1/3. 1/3 of 60 is 20. So we would expect to get about 20 rolls that were 5 or more. So it says underneath number 1 on the bottom of page 553, when we roll the cube as described in item 1, we expect to get an even number about half of the time. Another way of saying this is that when you roll the cube, the probability of getting an even number is 1/2. So to write this using probability notation, this is shorthand for the probability of getting an even number equals 1/2. So math people are always trying to find shorter, more efficient ways to write things. This, capital P and in parentheses even, means the exact same thing as this. In math, a lot of the times we're used to seeing parentheses telling us to multiply or function notation. It doesn't mean either of those things. You need to use the context that you're solving the problem in to help you understand what that means. So here's a helpful hint for how to write out probability notation. The probability of an outcome is written in symbols as capital P in parentheses outcome, where P stands for the probability. For example, the probability that the outcome is an even number can be written as the probability that the roll results in an even number, or simply as probability of even. So just look at how much more efficient it is to write these 7 characters than it is to write all this. So it says, when you roll the cube, what is the probability that you get a 5? Write your answer using probability notation. Well, how many possible outcomes are there? 6. Only one of those gives us a 5. So this is the probability of rolling a 5 equals 1 over 6. When you roll the cube, what is the probability that you get a number that is 5 or more? So the probability that it's 5 or more is 1 out of 3. And again, remember, how did we get this 1 out of 3? It's because out of 6 possible outcomes, only 2 of them, 5 and 6, were 5 or more, 5 or higher. So on the next page, on page 554, there's some important vocabulary that they have for us. Rolling the cube is an example of a probability experiment. A probability experiment is the process of observing an outcome when the outcome is not known prior to the experiment. So an example of this could be like flipping a coin or drawing numbers in the lottery. A result of a probability experiment is called an outcome. For the cube, the possible outcomes are 1, 2, 3, 4, 5, and 6. Those numbers that we listed out on the very first page of this lesson. This is really, really important. I teach AP statistics. So if you like probability, AP statistics later on would be a really, really fun class for you to consider signing up for. And we talk about sample spaces a lot in statistics. The name for the set of all possible outcomes is the sample space. So you can list the sample space inside braces here. That's all the numbers that we can get when we roll the number cube. You can't get 0, so 0 is not in there. You can't get 7, 7 is not in there. It's all the integers from 1 to 6 inclusive. Getting an even number when you roll the cube is an example of an event. So an event is any outcome or group of outcomes that come from a probability experiment. To get an even number, you have to roll a 2, a 4, or a 6. So that's 3 outcomes that we're putting together into one event. There are 3 outcomes that are even out of a total of 6 possible outcomes. In the long run, 3 out of 6, or 1/2 of the rolls of the cube, will result in even numbers. So generally, the probability of an outcome tells you what part of the time you would expect the outcome to occur. If all the outcomes in the sample space are equally likely, then the probability of an event is given by the number of outcomes in the sample space. So in other words, the number of total possible outcomes. That's what goes in the denominator. And in the numerator, we put the number of outcomes in the event. So it's what we're used to seeing whenever we write out fractions, right? Usually we're going to write out a part over whole. When we write out a fraction, it's the same thing here. The whole is the total number of outcomes in the sample space, the total number of possible outcomes that could happen in the probability experiment. And in the numerator, we put the number of outcomes that are in the event. So now let's answer some more questions based on what we saw with the number cube, but this is going to be a slightly different probability experiment. A regular solid is constructed with 4 faces. Faces are numbered 1 through 4, and the 4 outcomes are equally likely. We will roll this object once. Number 3, part A says, what is the sample space for this probability experiment? Well, a sample space is all the possible outcomes. If the faces are numbered 1 through 4, this is another way of saying, what are all the numbers that we could get whenever we roll the object? Well, the whole numbers 1 through 4 are 1, 2, 3, and 4, and we're putting that inside braces like we have right here, so that is the sample space. So now part B wants us to find the probability that the roll results in the following, and we're going to use probability notation for our answers. So the probability of rolling a 2 is 1 out of 4. There's only one of these numbers that's 2, so that's why we have a 1 in the numerator, out of 4, because there are 4 possible outcomes in the sample space. What's the probability of getting a number greater than 4? Well, how many of these numbers are greater than 4? 4 is equal to 4, but it is not greater than 4. So there are actually no numbers in this sample space that are greater than 4. That's why the probability of rolling a number greater than 4 is actually 0. Sorry, that should not be 0 divided by 6. That should be 0 divided by 4. 0 divided by 4 is 0. What's the probability that we get a number that is at least 2? Well, how many of these numbers are at least 2? At least means equal to or greater. So 2 is at least 2, so is 3, so is 4. So that's 3 numbers in this event out of 4 possible outcomes in the sample space. That's why the probability for this is 3 out of 4. And lastly, what's the probability that we get a number greater than 0? Well, how many of these numbers are greater than 0? 1 is greater than 0. All these numbers are greater than 1, therefore they're also greater than 0. So all 4 of them are greater than 0. That's why the probability of getting a number greater than 0 is 4 out of 4, which reduces to 1 whole. So now on the next page, page 555, there's some more summarization happening here. If an event can never happen, then there are no outcomes in the event, and so the probability of the event is 0. An example of this is something that's completely impossible. Like if today is Sunday and you say, what's the probability that I will wake up tomorrow and it will be Tuesday? Well, that's just not going to happen. That's impossible. So the probability of that event is 0. So on this number line, we would put that if the probability is 0, that means the event is impossible. If the event is sure to happen, then every element of the sample space is in the event, and so the probability of that event is 1. So this would be completely, like absolutely no doubts, it is going to happen, completely certain, then the probability is 1. That would be like if today is Sunday and you ask, what's the probability that tomorrow will be Monday? Well, that has to happen. There's no way that's not going to happen. So the probability of that event is 1. The probability of any event is a number between 0 and 1. How large the probability is tells us how likely the event is to occur. So if you have a 90% probability of winning a game, that means that you're more likely to win the game than if the probability is 50%, right? The probability of any event is a number between 0 and 1. That means that you cannot have a negative probability. That also means that you cannot have a probability higher than 1 as a decimal or higher than 100% as a percentage. That's why when your coach tells you, all right, we're going to give 110% in practice today, you should raise your hand and tell them, Coach, that's impossible. I can't go any above 100%. That's the same kind of thing that's going on here with probabilities. So when it says inclusive here, that means it can include 0 and it can include 1. The probability can equal 0 but cannot be less than 0. The probability can equal 1 but it cannot be more than 1. It can be written as a fraction, a decimal, or a percent. So now we're going to do some problems to make sure we understand what we've learned so far. Number 4 says, in probability, what is the word or phrase for the set of all possible outcomes? Well, that was just a vocabulary word that we saw earlier. That's the sample space. How is the probability that an event does not happen related to the probability that the event happens? Well, the probability that the event does not happen equals 1 minus the probability that it does happen. Something is either going to happen or it's not going to happen, right? If you have a 90% probability of winning a game, what's the probability that you will lose the game? Let's assume that the game cannot end in a tie. Well, 100% minus 90% gives you 10% left over. What's the probability that you do not roll a 5? Well, if the number cube is numbered 1 through 6. Well, if there's a 1 over 6 probability that you do roll a 5, 1 minus 1 over 6 could give you a 5 over 6 probability that you do not roll a 5. So this is an easy rule that will help you a lot when you're solving probability problems. What is the smallest possible value for a probability? Well, we already saw up here that's 0. What does that mean? That means that it cannot happen. That means the event is impossible. What is the largest possible value for a probability? That is 1. That means it is absolutely for certain going to happen. Okay, so let's keep on going to page 556. The contestants for the Springboard Superstar contest are as follows. The genders and ages of the contestants are in parentheses. So we've got 6 people listed over here, 6 people listed over here. There's a total of 12 different people. So we're going to select one of the 12 contestants at random. What is the sample space for this probability experiment? Well, the sample space is all the different possible contestants that we could choose, okay? So they just listed out everybody's name. So find the probability that the selected contestant is Casey James. Well, how many people are in this event? There's only one Casey James, right? How many people are we choosing from? 12. So that's why that probability is 1 out of 12. What's the probability that the randomly selected contestant is female? So we're going to highlight all the female contestants. Crystal is a female. Dee Dee is a female. Katie is a female. Lacey is a female. Paige is a female. And this is hard to say. For a long time when I would teach this activity, I would say Siobhan. That is incorrect. That is Siobhan. So how many of those contestants are female? 1, 2, 3, 4, 5, 6. Out of how many? 12. So 6 over 12 reduces to 1/2. That's how we get that probability. All right. What is the probability that a selected contestant has a last name beginning with Z? Well, nobody has a last name beginning with Z over here. Nobody has a last name beginning with Z over here. It's impossible to find somebody with a last name beginning with Z in this set of 12 people. What's the probability of something that's impossible? 0. Another way that we can see that is there are 0 people with a last name beginning with Z out of 12 people that we're randomly choosing from. What is the probability that the randomly selected contestant is under 30 years old? Well, Aaron is under 30. So is Andrew. So is Casey. So is Crystal. So is Dee Dee. In fact, it looks like everybody is under 30 years old. So that's 12 people are under 30 out of the 12 people that we are choosing from. So 12 divided by 12 reduces to 1. Another way to think about why that answer is 1 is it is completely certain that we are going to choose someone at random from this group of 12 people and they will be under 30. What's the probability of something that you know for sure is going to happen? It's 1. So what's the probability that somebody that we select at random has a last name beginning with B? Crystal's last name begins with B. Dee Dee's last name begins with B. Lacey's last name begins with B. So that is 3 people out of 12 that have a last name starting with B, and that can reduce to 1 out of 4. Now there's 2 ways to do part 6. What's the probability that someone does not have a last name beginning with B? Well, we could go through and we could highlight everybody that does not have a last name beginning with B. Okay, that kind of took a while because there are a lot of people that we highlighted. 5 people over here plus the 4 people over here gives us 9 people out of 12 that do not have a last name beginning with B. But remember, to find the probability of something not happening, we can simply do 1 minus the probability that it does happen. If I want the probability that someone does not have a last name beginning with B, I can just do 1 minus the probability that they do have a last name beginning with B. And so part C is going to kind of pick up on that. What do you get when you add the answers to parts 5 and 6? Well, the probability that an event happens and an event does not happen always add to 1. Well, we can take these two probabilities and add them up to 1. And the answer to their question is yes, when you add the probability that an event happens to the probability that the event does not happen, you are covering all possibilities. In other words, you are including all possible outcomes in the sample space. What's the probability of all possible outcomes in the sample space? That's a probability of 1. That's the probability of something that is certainly going to happen. So here's another summary. To generalize, when we add the probability that an event happens to the probability that it does not happen, we always get 1. From this, we can conclude that to find the probability that an event does not happen, we can subtract from 1 the probability that it does happen. This is called the complement of an event. So we already saw this in an answer earlier. The probability that an event does not happen is 1 minus the probability that the event does happen. This not event is called the complement of the event. Includes all possible outcomes of a probability experiment that are not outcomes of the event. So what's the complement of flipping a coin and getting heads, tails? What's the complement of playing a game and winning the game, losing the game, if the only possibilities are winning and losing? What's the complement of the event today is Monday? It's the event today is not Monday. So number 10 says Jenna and James were recently married and are planning on having 3 children. They are wondering how many girls and how many boys they will have in their family. Assume that they are equally likely to have a girl as a boy. 3 of the possible outcomes are shown in the organized list. There are 8 possible outcomes, and they want us to list the other 5 outcomes. So there's some questions like this on your homework. When you're trying to list out all the possibilities, it might be a good idea to list them out in a systematic, organized way. If you just try to write everything out as it first pops into your head, it's easy to miss out on some possibilities. So here are all the different ways that we can have 3 girls. First one is girl, second kid is girl, third kid is girl. That's the only way that we can have 3 girls. Well, if we want to think about all the ways that we can have 2 girls, that could be a girl and then a girl and then a boy, or a girl and then a boy and then a girl. But we could also have the boy first and then 2 girls. Those are the 3 ways that we can have 2 girls. Well, how many ways can we have 1 girl? Well, we could have the girl come last, or we could have the girl be born in the middle, or we could have the girl be the oldest. Those are the 3 different ways that we could have 1 girl. And lastly, there is only 1 way that we can have no girls. That would be all boys. So it says that there are 8 possible outcomes. We've got 8 outcomes here. So this shows us all the possible outcomes in the sample space. So now they want us to use this list to find some probabilities. Find the probability that in their family they will have 3 girls. Well, there's only 1 way that will happen. So that probability is 1 out of 8. Find the probability that they will have exactly 2 girls. Well, they could have girl, girl, boy, or girl, boy, girl, or boy, girl, girl. That is 3 different possibilities where they have exactly 2 girls out of 8 total, so that's a probability of 3 out of 8. So now I'm going to have to use some different colors to highlight here. We're going to do blue for number 3. The probability that they have at least 2 girls. Well, that could be exactly 2 or more than 2. So that's 4 different possibilities where they have at least 2 girls out of 8 total possibilities. So that's a probability of 1 out of 2. C says, what is the probability that they will not have exactly 2 girls in the family? So the easiest way to do that is if we know that the probability that they have exactly 2 girls is 3 out of 8. To do the not probability, we can do 1 minus that. And 1 minus 3 over 8 gives us 5 over 8. If we wanted to check that, we could simply take out this possibility. Say, let's highlight everything where they do not have exactly 2 girls. Well, this is not 2 girls. Neither are all 4 of these. So that's 1, 2, 3, 4, 5 out of 8. So that's one of my favorite things about probability. It's really, really easy to check that you have solved the probability question correctly. If you find the probability of every single possibility and you add those probabilities up and you get 1, then you're feeling pretty confident that you have solved the problem correctly. All right, so lastly, here's 2 check your understanding problems. At the top of page 558, Iris rolled a 5-sided number cube numbered 1 through 5. Find the probability that a roll will result in each of the following. Write your answer using probability notation. Well, let's list out all the possibilities in the sample space. That would be, we could get 1 or 2 or 3 or 4 or 5. That's a good problem-solving strategy whenever you're doing probability problems. So what's the probability that she will get an odd? Well, out of 5 possible outcomes, 1, 3, and 5 give her odd numbers. So that's 3 odd numbers out of 5 total numbers in the sample space. B says, what's the probability that she does not get an odd number? Well, that would be, to do the not probability, we can do 1 minus 3 over 5 is 2 over 5. Or we can also see that 2 and 4 are not odd numbers. Those are the 2 not odd numbers out of 5 possible outcomes. C says, what's the probability that she gets a 4? Well, there's only 1 4 in this set out of 5 possible outcomes, so that's 1 out of 5. And then just like we did part B, we can do part D by using that complement trick. 1 minus 1 out of 5 is 4 out of 5. Or we can see how many of these numbers are not 4. Well, 1 is not a 4, 2 is not a 4, 3 is not a 4, 5 is also not a 4. That's 4 numbers in that event out of 5 possible outcomes in the sample space. Okay, number 12 says Fiona's dog Sunshine is expecting a litter of 4 pups. The chance that the pups will be male or female is equally likely. What is the probability that the litter will contain 2 males and 2 females? Make an organized list to determine the probability. Okay, so we're going to look at what this organized list looks like. See, here is all the ways that we can have 4 males. And then underneath that, we've got all the ways that we can have 3 males. And then underneath that, there's all the ways that we can have 2 males. And then underneath that, there's all the ways that we can have exactly 1 male. And the only possibility that we haven't covered is having no males, having all females. Now, why do we do that? Because that's kind of tedious and that's not the most exciting thing you could do in a math class. Well, if we want the probability that the litter will contain 2 males and 2 females, in order to work out a probability problem, we need to know what number to put in the denominator. That's how many possible outcomes are in the sample space. Well, now that we've worked all this out, we can see that there are 16 possible outcomes if you count all these up. 1 plus 4 plus 6 plus 4 plus 1 is 16. Well, out of those 16 possible outcomes, how many are showing us exactly 2 males and exactly 2 females? Well, that's 1, 2, 3, 4, 5, 6. So 6 out of 16 reduces to 3 out of 8. So hopefully this practice helped you with regaining what you may have seen before about probability. Thank you guys so much for your hard work today.